Hello, JNV Ramnagar. Good morning. How are you? Uh, I hope the screen is visible to you and I'm audible to you. If it is so, please put this message on the chat box or put a yes in the chat box if it is okay for you. Please make sure the screen is visible to you. Is it? And I'm audible to you? Student of JNV Ramnagar, are you there? If you confirm this, then I will start the class. Okay. So I will consider that screen is visible to you and I'm audible to you. Okay. So today we are with our lecture number 5 on question discussion of work, energy, and power. So this will be the last session. I have put most of the previous year question in this. So we are trying to solve them one by one. Okay. And I hope you will enjoy this session. So let's just get started with it. Now the very first question on your screen is this. This is a very conceptual question and very important question too, because every year the question has been asked from this concept. Although the language has been changed, but the question, the concept would be same for each time. And you will see as we will move further, you will see that previous year question has been asked from this concept. So the question is that a chain of mass m and length L is held at rest on a smooth horizontal surface such that a portion of the chain is hanging vertically. So taking the level of horizontal level as the reference line, calculate the potential energy of the chain at this instant. And if the chain is let go, what is its speed as its end just leaves the horizontal surface. Okay, so I hope you got the question. So here in this question, a smooth horizontal surface is given to you. Let's say this is the horizontal surface. Okay, and this is the chain line on it. Okay? So this is the chain line on it. और इसका कुछ part is hanging down. Okay. So this surface is smooth. This surface is smooth. So there is no friction. So we have to take the level of horizontal level, means this level, as the reference line for calculating the potential energy. Because for potential energy, we need a reference line from where we measure the height or change in the position of the object. Okay. So this is our reference line. Now we need to calculate the potential energy of the chain at this instant. Okay. So we know that now I want you to try to solve this question. And for that, I'm giving you 1 minute. Try to solve this question and let me know the answer. Okay. So are you trying to solve this question? Okay. I hope you are trying to solving this question. Now, if you will see that portion, let's say the downward portion has a length L, small l, and the complete length is capital L. So this length would be capital L minus small l. Okay. You know that on reference level, the potential energy is zero. The potential energy is zero at reference line. At reference line. So when the potential energy is zero at the reference line, which means this capital L minus small l, this length would have no potential energy. Only the length which is hanging down has the potential energy. Okay. So we need to calculate that. Now we know that for this hanging part, I'm writing it here. We know that the mass is not at a particular point. Mass is distributed. So as you move down, let's say this portion, it has a mass. But when you increase this length, the mass will increase. The mass will constantly increase. So in the expression of potential energy, there is a U is equals to mgh. But here, the mass is varying. Mass is varying. So we have to take a elemental length and then we have to consider a elemental mass and we have to calculate the change in potential energy for that elemental mass. So what we are going to do from the reference line at distance x below, we have considered a small portion of this chain which is dx and having a mass dm. Okay. So we can say that the potential energy, change in potential energy here is dmgx. Now, would it be plus or minus? Because we are moving down or we are moving below to the reference line. So the potential energy should be negative. Because downward direction is negative, upward direction is positive. So we will consider it to be minus dmgx. Now we need to calculate this dm. What is this dm? How we are going to calculate this? So we know that at length capital L, the mass distributed is capital M. So for unit length, what is the mass distribution? This is mass per unit length, which is the linear density of it. So for dx length, what should be the mass distribution? For dx length, it should be m by L into dx. And this is nothing but equals to d. Okay. So put this value in this equation 1. Du is equals to minus dmg. So du is equals to minus of dm gx minus dm is equals to m by capital L dx into g into x. If we arrange it, it will become mg by L minus mg by L into x dx. So this is the value of du. Now, du here we have got is minus mg by L d, sorry, minus mg by L x dx. Now, if we integrate it from the reference line to the small length L, small l, because we have considered this hanging part length should be small l. So we can consider it to be like at 0 at the horizontal level, reference line, the potential energy is 0. At L, potential energy is U. Also, we can say that U minus 0 is equals to minus mg by capital L integration 0 to L x dx. Now, this is U minus mg by capital L, and to this will become L square by 2, because integration of x ds will become x square by 2, and if you put the limit, it will become L square by 2. So the change in potential energy from the reference line to the length L down the reference line will be minus mg by 2L into L square. So this is the potential energy. So first portion we have covered. So taking the reference level, horizontal level, calculate the potential energy of the chain at this instant, and we have calculated this. Now, in the second portion, what has been asked, that if the chain is let go, then what is its speed as its end? End means not end, one of the end of it, like this one. Just leave the horizontal surface, which means now in the second portion, now this is the table on which this chain is placed. The end part of it, will be leave the horizontal surface. Now the complete length 0 to L, complete length capital L is being in downward direction. Okay, is move away from the horizontal surface. Okay, so here the capital length L is completely removed from the horizontal surface, and we will consider that at this instant the velocity of the chain is v, small v. Now, so what we can say, we would know that here this length, though this chain is lying on a smooth horizontal surface, which means there is no friction. Okay, if there is no friction, and when the chain leaves this horizontal surface, the normal reaction will also vanish. So there is no net external force which is acting on this chain. So we can conserve the mechanical energy of this chain. What we can say? Kinetic energy initial, potential energy initial equals to kinetic energy final plus potential energy final. Okay. So initially kinetic energy is 0. Initial potential energy is also 0. If you put this kinetic energy final, which is 1 by 2 mv square, let's say, plus, or should be minus, because all the mass is in the downward direction from the reference line. We know that for small l portion, the potential energy is mg by 12 L square. So if we put small l is equals to capital L, because now the complete chain is move away from the horizontal surface. So U is equals to minus mg by 2L into L square, and you can cancel this L by this. So it will be minus mgl by 2. So we would put that as minus mgl by 2. Take this portion on the left hand side. So mg capital L by 2 is equals to 1 by 2 m p square. This m and m will cancel out. 2 and 2 will also cancel out. So v you will have as root g. Okay. So this is the velocity with which the chain will move when its end leaves the horizontal surface. Okay. Now, so this is the question from JEE Main 2020, the latest you will say. In this question, a particle of mass 1 kg slides down a frictionless track AOC, starting from rest at a point A at height 2 meters. After reaching C, the particle continues to move freely in air as a projectile. So when it reaches its height, point P, which is as a height of 1 meter, the kinetic energy of the particle is. So we have to consider G, which is the gravitational acceleration, as 10 meter per second square. Okay. Now, solution of this question. I have considered this question because by seeing this portion of question, the student will think that this will be a very tough question because there are number of lines in this question. Okay, and the graph is also given, a portion is also given. So they will just lose their confidence and move on from this question. But you will see that this is a very easiest kind of question that you will have in your examination. So if you read this question carefully, the hint and the answer is lying within the question. You will see that this is the frictionless track, which means there is no frictional forces are there. Okay. The particle is started from rest, which means the initial velocity is 0. Okay. When there is no friction, means there is no non-conservative type of forces. If there are not any non-conservative force, we can say that the potential energy and kinetic energy will be conserved. The total energy of the system will be conserved because there is no non-conservative type of forces are there. Okay. Only mg will act, which is the weight of the ball or weight of the particle, and mg you will consider as a conservative force. So only conservative forces are acting here. So we can apply the conservation of mechanical energy, and you will see that how simple is this question become. You will see at this point A, the height is 2 meter. If I take this line to be a reference line, okay. So we will measure the potential energy from this point, from this line. So initially, if you write this expression that kinetic energy initial plus potential energy initial is equals to kinetic energy final plus potential energy final. Now, initial kinetic energy you will have as 0. Why it is so? Because the question says you that a particle starting from rest at point A, which means the initial velocity is 0, And if the initial velocity is zero, the kinetic energy will also zero. So this kinetic energy initial will be zero. Now what about the potential energy? So potential energy is given by mgh. H is already given to you at point A, which is 2 meter. So you can write it as 1. The value of m is 1, g is 10, and this height will be 2. This is the potential energy initially. Now finally we do not know the velocity of this point P, so we would consider that it should be V. So the potential energy will become half mv square. Then m is nothing but 1, so we would write it as 1 by 2 v square plus u finally, final potential energy. Final potential energy at the point P we have to see. Now it is also given to you in the question. When it reaches its height point P, which is the height 1 meter. So mgh 1 into 10 into 1. This is 20, this is 10. If you take this on LHS, it will become 10. So 1 by 2 v square is equals to 10. Okay. So here we can say that if you consider the mass also, which is 1, so this entire expression is nothing but the kinetic energy. This is the kinetic energy, which is equals to 10 joule. And that has been asked to you. Okay. The kinetic energy of the particle has been asked. So the right answer is 10 joule. Look how simple is this question is. Okay. So try to think conceptually that what concept I can apply on this question, what has been exactly asked, and what should I do for that. Okay. Now kinetic energy you can calculate by two ways. First is the work energy theorem, and second is the kinetic energy by conservation of mechanical energy. You will see here there is no such kind of thing that you can apply the work done. Although you can apply the work energy theorem, but you need more time, more spaces to solve this. But if you go through with the potential, the second concept you left is the conservation of mechanical energy. We have applied it, and by 2 to 3 lines we have got the answer. Okay. Now, the similar question based on the concept I have taught in the very first question. In the very first question. So we will try to solve this question also. A uniform cable of mass capital M, length capital L is placed on a horizontal surface that is 1 by nth of its part is hanging below the edge of the surface. To lift the hanging part of the cable up to the surface, work done should be. Now in this case, we have to lift the part above the, we have to lift the hanging part of the cable up to the surface. Then what should be the work done? We need to do. So simple. You know that if this is the question, some of the part of the chain is hanging down, and we have considered it to be a length, and we know that this length L is the 1 by nth of entire length. So we will keep this in mind that L is here is equals to 1 by n of capital. So again, we have to consider a elemental mass at a distance x from the down to the horizontal level, and this horizontal level we have considered the reference line. So again the du will become here minus dmgx. You don't need to apply this again and again. You just learn the formula and apply directly to it. So du here is integration of this. Dm, you know, it is nothing but mass upon length into dx into x into g. So we can say that integration of du is equals to mg by, and the minus sign also there, minus mg by capital L into x dx. Again, we integrate it from 0 to small l, because small l is the portion down to plane. And here 0 to u. So you will have as potential energy, you will have as minus mg by capital L into L square by 2. Now, put the value of small l in the terms of 1 by n into L. So if you put it, that minus mg upon L into L square by n square into 2. So you will have as Ly cancel one power of it, minus mgl upon 2n square. Okay, this is the potential energy of the particle. Now we need to calculate the work done of it. Okay, so we know that in this question also, horizontal surface पे this chain is placed, so there is no such kind of friction that has been mentioned in this question. So we know that if the potential energy exists, there must be no friction. Okay, if the friction is not there, we can say that the potential energy or the kinetic energy, sum of the potential energy and kinetic energy will be conserved. So the mechanical energy, total mechanical energy is conserved. Okay, but what about the work done? We know that in conservative field, the work done is given by the change in potential energy. Okay, we know that the work done by conservative force is nothing but minus of change in potential energy, or you can say that opposite of that, the change in potential energy is nothing but minus of the work done by conservative force. So if you put this, because you have to change this potential energy, you have to lift this part off. So what should be the work done? Work done should be the exactly this, because you have to work done against the conservative forces, which is mass into gravitational acceleration. So you can say that work done here is minus of change in potential energy. So change in potential energy we have to consider only for this portion, because the portion on the above the surface has a zero potential energy. So minus this we have calculated. It is minus into minus will become plus mgl divided by 2n square. Look how simple is this. Okay, got it? So this option is the correct option. Got it? Now, if you talk about that, we have calculated it for the very first question. It is minus mg by 12 into L square. Minus mg by 12 into L square. If you put the value of L here, you will see that minus mg by 12 into capital L square by n square. So directly you will have the expression without applying this dm and m. Without applying the formula of dmgx, without calculation of dm, you have directly you will have as this. You can apply to this. Okay. Now, got it? Now, the next question on your screen is this. A particle is moving in a circular path of radius a under the action of an attractive potential U is equals to minus k over 2r square. Its total energy. So in this question, we need to calculate the total energy of the system. And for that, how we are going to move. Here, the potential function is given to you, which is U is equals to minus k over 2r square. So the solution of this question is, okay, we know that we know that this u, which is minus k over 2 r square. Okay. So conservative field, for a conservative field, we know that the force is given by minus of del u by del x I cap minus del u by del y j cap minus del u by del z k cap. Okay. So these are the potential gradient we would consider for one, and we will apply on this. So we can say that this f vector for this question will be minus of del u by del r cap. Okay. Now, if we are able to calculate the force, we can calculate the work done in this case. Okay. Force, which is mv square by r in this case, because it is a circular path motion. If we are able to calculate the v square portion, we can calculate the kinetic energy of the system. Got it? Now, and from where it has been coming, you are wondering with this. You know that in a conservative field, work done by conservative force is negative of change in potential. You can say that work done by conservative force to be F dot dr. It is minus of du. So you from here you will say that it will become minus del u by del r. Got it? Now, for this you need to calculate the force vector. So force here will be, this is the partial differentiation. So only r will be differentiated. So it will become minus k by 2 into del by del r of 1 by r square. Now we know that differentiation of 1 by x square will become minus 1 upon x. Okay, because x square will go up, it will become x raised to the power minus 2. And according to the formula, n x raised to the power n minus 1 will be the differentiation. So it will be minus 2 into x raised to the power, it will become minus 2 divided by x cube. Okay. So here again, it will become minus k by 2 into minus 2 by x cube. And x here is r. So minus minus will cancel out each other. Minus minus will become plus, 2 will cancel out. So it will become k upon r cube. And for that we have to consider it to be this is force. We know that in circular motion, the force is given by mv square upon r, which is equals to k upon r cube. But here the r is nothing but r is here is radius of the path is given by a. Okay. Now we know that this will become a. So the v square will have as a upon m k upon r cube. If you multiply this term with 1 by 2 times fm, also this side 1 by 2 times of m, the m and m will go cancel out with each other, and you will have you will have 1 by 2 times of mass into velocity square is equals to a k divided by 2r cube. Okay, so just give me 10 seconds. I'll be right here. So sorry for the disturbance. There are some network issue. Now, so here we have considered that this kinetic energy, this is 1 by 2 mv square, will become a upon 2r cube. We will put this a to be small r because we are calculating all of this with respect to a circle of radius small r. So if we put it r, it will become k upon 2r square. If you talk about the total energy will be potential energy plus kinetic energy. The potential energy will be, it is given to you, minus k upon 2r square, plus the kinetic energy you will have as k upon 2r square. So both will cancel out each other and the total energy you will have as 0. Okay. So total energy is 0 in this case. Now, I hope you got this. If you have any kind of doubt or any kind of problem you will have at a particular point, you will ask in the chat box and you can write this in the chat box. Now, this is a very simple question and yet to be asked in 2020, and it has been repeatedly asked 2 times in 2019 and 2020. Okay. So particle moves in one dimension from rest, which means the initial velocity is 0, under the influence of a force that varies with the distance traveled by the particle as shown in the figure. The kinetic energy of the particle after it has been traveled 3 meters is, which means complete distance it has been asked. We know that if the force is variable, we know that you can try to solve this question. Okay. We know that if a force is a variable, this is a variable force with respect to the distance. So we know that the area under this curve and area under fx curve will give you will give you will give us work done. Okay. So here in this question also the graph is being given to you. So simply what you have to do, you have to calculate the work done. And as well as soon as you get to the work done, you will apply the work energy theorem to calculate the kinetic energy of the particle. Okay. So there are two area in this figure. This is the area number one, which is a rectangle, or you can say the square. It is a square. And this portion, again, area number two, which is a rectangle for sure. And this area, which is a triangle. Okay. So area under fx curve is equals to work done. So work done here will be from 0 to 3, the complete area under this curve. So it will be this square, which is 2 into 2. The area of the square is length into height. So 2 into 2 plus this rectangle. This rectangle has this length as 1 and the height is 2. So it will be 1 into 2 plus area of the triangle is given by 1 by 2 into base into height. What is the base? Base is 1. But what is height? You will not consider this to be height. Height only been considered from this, from the base. So height is also 1 because 3 minus 2 is 1. And 2 to 3, the base is also 1. So it is 1 into 1. Now you will have 4 plus 2 plus half. It will become 2 plus 4 will become 6 plus half, which means 6 and half, or you will say that it will become 13 by 2, which is nothing but 6.5. Okay? This is the work done, which is joule. Now, we need to calculate the kinetic energy of the particle as it had traveled at 3 meters. So we apply the work energy theorem, which is nothing but work done is equals to the change in kinetic energy. We know that it is K final minus K initial. Initially, the particle is at rest, which is given in the question. So initial kinetic energy will be 0. So finally, what you will have work is equals to K final. Okay. So kinetic energy finally you will equals to the work done, and work done you have already calculated, which is 6.5 joule. So the kinetic energy will also be 6.5 joule. So option C is the correct option. Okay. I hope you got this. Now, move on to the next question. A body of mass 2 kg is driven by an engine delivering a constant power 1 joule per second. The body starts from rest, moving in a straight line. After 9 seconds, the body has moved a distance. So we need to calculate the distance. Now, try to solve this question. Okay. So in this question, what is given to us? Firstly, write the given data. So what is given to us is mass of the body, m is equals to 2 kg. Constant power P, which is 1 joule per second. and the body started from rest, which means v u initial is equals to 0, and it moving in a straight line, and the time period is given to you as 9 seconds, for which you have to calculate the distance traveled by this. Okay, so what we are going to do, we know that power p is equals to force into velocity. This is the formula for power. Now, force is also can be written as mass into acceleration into velocity. Power is equals to mass into acceleration, you can write as dv by dt into v. Now, you can take this dt on this side on LHS, so it will become mv dv is equals to p into dt. You can take this m to be in the RHS side, so v dv is equals to p by m into dt. Okay. So final velocity you will calculate as v dv p by m into dt. ठीक है. So integrating this 0 to t, 0 to v, because initially the velocity is 0. So you will have v square by 2, because integration of v dv will become v square by 2 into p by m into t. Okay. Again, you can say that this v square will become 2pt by m, because we are not interested in velocity, we are interested in the distance traveled. Okay, got it? Okay, so if you are able to calculate the velocity here, I can tell you two methods to solve this. If you have this v square, put the value of power, which is 1 joule per second, time you have to calculate 9, mass is given to you. So v square you have 3 meter per second. The final velocity we are interested in. Okay. Now take this expression. P is equals to ma into v. P is equals to m into a into v. Power you have as 1. Mass you have as 2. Acceleration you don't know. Velocity you will have 3. So acceleration you will have as 1 by 6 meter per second square. Okay. Now we know that the formula here you can use is v square equals to u square minus or plus 2as. Initially the velocity is 0, final velocity you will have 3, so it will become 9 into 2, acceleration you have as 6, 1 by 6 into s. 2 into 6, it will become 3. So s you will have as 27 meter. Okay. 9 3 is a 27. This will be the method. Or what you can do, you can take this expression v square is equals to 2pt by m. Again, what you are going to do? You are going to square root of it. It will become 2pt by m. And then you can write dv to be dx by dt is equals to square root of 2pt by m. And then you can calculate dx is equals to square root of 2p by m square root of t dt. And you can calculate it from 0 to 9 second, and here also 0 to yes. So by this expression also you are going to get the same answer. Okay. Got it? So this is it from my side. If you have any kind of question, you can ask. Otherwise, the lecture is being over. Okay. Thank you so much for being attentive, but you have to be responsive. So if you don't respond, if you don't say कि ये समझ में आया या नहीं आया, then how will I know कि you got this or not? ठीक है. So it is for your good. So try to be responsive. Try to be ask question in the. Try to be doubtful in the session. You will have doubt, so that I will consider. ठीक है. So try to be responsive. Attentive you are, but responsive you have to become. Thank you so much for being attentive.